relative motion is the motion of the objects relative to each other, or the motion of these objects relative to a reference. So when you see two cars speeding on the highway, you will say car A is faster than car B, or car C is slower than car A and B. In this case, you are analyzing in your brain relative motion between these cars. Whoever is advancing or progressing in speed faster than the other one, then you will say this car is faster than that car is slower than this. And you could be either in your car on the highway judging those cars, or you could be even standing on the side of the road and telling which car is faster and which car is slower, which car is moving forward, which car is moving backward, and so on. So that is called relative motion in its simplest form. In many cases, relative motion is related to one, two, or many objects that are moving relative to each other or relative to a reference. In this case, we are seeing a production line, even it's cartoonist illustration, but just to get the idea. So you have the robotic arm over here carrying some materials from one place to another. Each of those cups is moving on a conveyor belt. So the cup is moving at the speed of the conveyor belt, and the robot have his own speed and transition from point A to point B to point C and so on. So when you have such kind of a motion, in this case relative motion is involved. So if you're standing on a conveyor belt, in this case, you will see the motion of the robotic arm is different than when you are standing on the floor away from the whole scene. So we will talk more about what is the relative motion and how to set up the right perspective to judge the relative motion of objects. Now first we say the motion is relative to the ground. So when you see a train on its track and you are standing like far away on a mountain or on the side of the road, then you are telling that train is moving in a certain speed. You, as standing on the floor and judging the speed of the train, you are called an observer, in this case ground observer. And the train is the moving object. In this case, he's moving relative to the ground or relative to the trail which is on the ground. So you are judging his speed. So your reference in this case is the ground or the rail. Now, as well, we talk about the motion relative to the air. When you have an airplane flying 10 kilometers above the ground, and in this case, you are judging the airplane speed. Could be relative to the ground, could be relative to another airplane beside it, could be the speed of the airplane relative to the air around it. Is the air flowing in the same direction of the airplane or in the other direction of the airplane? We will use what we learned about vectors and vector components, how to analyze such motion and solving all the problems related to such scenario. So in this case, we have an airplane that is moving east on a speed of 789 kilometers per hour, and the wind speed in that case is 56.3 kilometers per hour east as well. It's important to know when you're talking about motion relative to air, there is something called ground velocity. So that's the velocity relative to the observer on the ground. Whoever is looking at the airplane and judging its speed on the ground, we call it ground velocity because the observer is on the ground. There's as well air velocity. That is the object velocity relative to the still air. So the air is still, in this case, the airplane is moving with the power of engines, the jet engines in this case. So we call it V air. It's basically the V of the airplane or the speed of the airplane. Then we have the wind velocity. That's the velocity of the wind relative to the ground. You know, the wind is flowing in a certain speed relative to the floor or to the ground. That's the V wind. Now, if we want to analyze that motion in vectors terms, so we know that the V ground equals the V air or V airplane plus the V wind, because both are directing east. So we have V air with a certain magnitude and direction. V wind is in the same direction. So the V ground or the total displacement or the total speed in this case equals the V air plus V wind. 789 plus 56 will give you 845 kilometers per hour. That's in the direction of east. Now, what if the airplane was going west for a speed of 789 kilometers per hour and the wind speed, the regular speed, is 56.3 kilometers per hour east? So we have two different directions of speeds for two objects. So we have air to the left and v wind to the right. What is the v ground? From the tail of the first to the head of the last. That's the total v. In this case, you would say v air plus v wind. The v air going left, that's minus 789 kilometers per hour, plus 56 would give you ground speed of minus 733 kilometers per hour.